Which statement is false? Option A says, the order in which two whole numbers are subtracted does not affect the difference. So when we're subtracting numbers, the answer is called the difference. So let's consider two whole numbers. Let's say we have 5 and 3. So this option says that 5 minus 3 and 3 minus 5 give the same answer. Well, do they? 5 minus 3 is 2, and 3 minus 5 is negative 2. So the order in which two whole numbers are subtracted does affect the difference. It does affect the answer. So we can say option A is false. And we have our answer. If you were taking the test, you can move on to the next question. But let's go ahead and look at these other options here to make sure we understand them. Option B says the order in which two whole numbers are added does not affect the sum. When we're adding two numbers, the answer is called the sum. So let's consider two whole numbers. We could use 5 and 3 again. We're talking about the order in which we add them. So we could think about 5 plus 3 and 3 plus 5. 5 plus 3 is 8, and 3 plus 5 is 8. So the order in which two whole numbers are added does not affect the sum. This is true. Option C says the order in which two rational numbers are added does not affect the sum. So this is similar to option B. Instead of whole numbers, we're talking about rational numbers. A rational number is just a number you can write as a fraction. So 2/3 would be a rational number, 4/5, basically any fraction. However, whole numbers you can also write as fractions. We talked about 5 and 3 before. 5 can be represented as 5 over 1, and 3 could be 3 over 1. So whole numbers are rational numbers. So our example from option B works in this case too. We're adding two rational numbers, and the order does not affect the sum. That is true. Option D says the order in which two rational numbers are multiplied does not affect the product. When we're multiplying numbers, the answer is called the product. So let's multiply two numbers. We could say 5 and 3. Those are rational numbers. They can be represented as fractions. So 5 times 3 and 3 times 5. They both give us 15 because we can multiply numbers in any order. So the order in which two rational numbers are multiplied does not affect the product. That is true. So our question asked which statement is false. The only one that's false is option A. Number 5, which number does not have a reciprocal? So what is a reciprocal? We use this word when we're talking about fractions, and a reciprocal is just a fraction flipped. So let's consider each of these options as fractions. -1 can be rewritten as -1 over 1. 0 can be rewritten as 0 over 1. 1 over 1000 is already a fraction. And 3 can be rewritten as 3 over 1. So the reciprocal of each of these options would just be the fraction flipped. So instead of -1 over 1, we have 1 over -1. And that equals -1. For 0 over 1, we just flip that to get 1 over 0. So we could say that 1 over 0 is meaningless. And since 1 over 0 is meaningless, we say that 0 does not have a reciprocal. So our answer would be B. Let's go ahead and consider the last two options. So the reciprocal of 1 over 1000 would be 1000 over 1, and that just equals 1000. And the reciprocal of 3 over 1 would be 1 over 3. So A, C, and D, these options all have reciprocals. The only one that does not would be option B. What is the multiplicative inverse of 1/2? So let's think about what this term, multiplicative inverse, means. Let's say we start with the number 5 and we multiply it by 3. That means we started with 5 and we ended up with 15, because 5 times 3 is 15. Now, how would we get back to 5? Well, if we started at 15, we could just divide by 3. Or in other words, we could multiply by 1/3. So we started at 5 and we ended with 5. And that's because multiplying 3 times 1/3 just equals 1. So essentially, we just multiplied 5 times 1. So the multiplicative inverse is what you multiply to undo the first multiplication. So when we had 5 times 3, to undo that times 3, we had to multiply by 1/3. So 1/3 was the multiplicative inverse of 3 because it undid it. Another example, let's say we have 2 times 4. What would you multiply to undo this times 4? You multiply by 1/4 because 4 times 1/4 just equals 1. And so we're left with 2 again. So 1/4 is the multiplicative inverse of 4. So looking back at our question, what is the multiplicative inverse of 1/2? If we're multiplying some number, let's say 10, by 1/2, then what number do we have to multiply it by to undo it? So essentially, 1/2 times some number has to equal 1. And in this case, what would our question mark be? That would be 2. And that would be option D. Number 19, which number serves as a counterexample to the statement below? And the statement is all positive integers are divisible by 2 or 3. So a counterexample is just an example that proves something wrong. So let's say that you have a classmate who says all balloons are red. Well, if you show them a purple balloon, then you've proven them wrong, because they said all balloons are red, and you showed them a balloon that's not red. And in this question, it says all positive integers are divisible by 2 or 3. So if you want to prove this wrong, just find a positive integer that's not divisible by 2 or 3. Let's make a note of that. So we want to find a positive integer that is not divisible by 2 or 3. Okay, let's consider 100. Well, 100 is divisible by 2 because 100 divided by 2 is 50. So that does not work. 57 is not divisible by 2, but it is divisible by 3. You can check that in your calculator. That would not work. 30 is divisible by 2 and 3. 30 divided by 2 gets you to 15, and 30 divided by 3 equals 10. So just by eliminating our 3 choices here, we know that our answer has to be D. But let's check. 25, is it divisible by 2? No. And is it divisible by 3? No again. So 25 is a positive integer that is not divisible by 2 or 3. So it is a counterexample. Your classmate is saying that all positive integers are divisible by 2 or 3, and you show them 25. That proves them wrong. Number 21. Which of the following is a valid conclusion to the statement? If a student is a high school band member, then the student is a good musician. So the question is asking, based on this statement here, what can you say? A valid conclusion is something that's based off of just that information. Option A says all good musicians are high school band members. Well, our statement is saying if a student is a high school band member, then they're a good musician. So writing it more simply, you could say in the band, that means good musician. But option A is saying if you're a good musician, that means you're in the band. That is not what our original statement is saying. So we can mark that off as incorrect. It is not a valid conclusion. Option B says a student is a high school band member. So it's saying if you're a student, then you're in the band. That's not what our original statement was saying. Our original statement said if a student is in the band, then they're a good musician. Not that every student is in the band. Similarly, looking at C, all students are good musicians. So this is saying if you're a student, you're a good musician. Well, our original statement said if a student is in the band, then they're a good musician. Not that all students are good musicians, only if they're in the band. And so, based on this, D should be the right answer, but let's check. All high school band members are good musicians. Well, this is saying if you're in the band, you are a good musician. That is exactly what our original statement is saying. So these kinds of questions can be a little tricky. I encourage you to write out little notes like this. If you can make the statement a little simpler, then you can focus on the logic. So option D, all high school band members are good musicians, just says if you're in the band, you're a good musician. So it's easier to think about that way. Number 25, when is this statement true? The opposite of a number is less than the original number. Okay, let's consider a number. Let's say we have 7. So the opposite of a number, that would be -7. So in this case, our original number is 7, and the opposite of a number is -7. So -7 is less than 7. That is true. And this would be true for any positive number. If you have a positive number, the opposite would be negative, and a negative number is always less than a positive number. So we can say that this statement is true for positive numbers. Let's take a look at our options. Option A says this statement is never true. Well, we just gave a counterexample. We showed that it is true for positive numbers, and in particular, 7. Option B, this statement is always true. We don't know that for sure. We know it's true for positive numbers, but we're not sure about all numbers. So let's just say maybe. Might be true. Option C, this statement is true for positive numbers. We know that's true. And option D, this statement is true for negative numbers. Okay, let's consider that. Let's say we have a negative number. Let's say -4. Let's look at our statement and plug in this new number. So our original number here is -4. The opposite of that number is 4. So the statement says 4 is less than -4. That is not true. If we start with a negative number, the opposite is always going to be positive. So this statement is saying that a positive number is less than a negative number. And that is not true. So we can say that this statement is false for negative numbers. So we can cross out D, and we can also cross out B because it's not always true. We can say that it's true for positive numbers.